My name is Michael Geigert, and I'm an air quality forecaster for Connecticut DEP. I will be presenting how we use satellite data to track trends in emissions of pollutants. Specifically, I'll be showing you the reductions in nitrogen dioxide emissions during March 2020. First, we'll talk about criteria pollutants. The Clean Air Act requires EPA to set national ambient air quality standards for 6 common air pollutants. 6 pollutants are particulate matter, ground level ozone, carbon monoxide, sulfur dioxide, nitrogen dioxide, and lead. Of the 6 pollutants, particle pollution and ground level ozone are the most widespread health threats. Ground level ozone is a secondary pollutant formed in the presence of volatile organic compounds and oxides of nitrogen. Connecticut has set up a monitoring network to measure compliance with these standards. Technology has evolved such that many of these chemical compounds can now be detected by satellites, and we will be exploring recent changes in the nitrogen dioxide concentrations. This is a rather complex flow diagram showing the many sources of both man-made and natural pollution. Besides the obvious man-made air pollutants from industry, transportation, and agriculture, you will notice emissions from dust, biomass burning, and sulfur from the oceans. Some of these pollutants undergo a chemical transformation to form ground-level ozone, and then are transported downwind. Of the 6 criteria pollutants designated by EPA, we will be examining the nitrogen dioxide satellite trends. This is a video by the European Space Agency illustrating how a polar orbiting satellite collects data on several chemical species. These satellites have been critical for tracking the size of the ozone holes over the poles, and we will be looking at recent trends from the nitrogen dioxide data. The next 3 slides are from the Aura-OMI satellite instrument, which has been in operation since 2005. The first slide will show the 5-year mean NO2 concentrations for the month of March. The following slide will show the concentrations for just March 2020. The third slide will be an animation showing the variation from each year. It appears that NO2 levels over the I-95 corridor from Washington, D.C. to Boston have decreased by 30% during March 2020. Here is an image showing the average NO2 concentration for the period of March 2015 to 2019. Notice that the highest concentrations occur along the I-95 urban corridor, especially around New York City. Now, this is the image that shows just the average for March 2020. Notice that the NO2 concentrations have significantly decreased. Here's the animation showing the averages for March for each year from 2015 to 2020 using a different scale. Notice that March 2020 is much less than a previous March during the past 5 years. Keep in mind that this data is still preliminary and needs further review. Satellite data is highly dependent on the weather, and cloud cover will generally obscure the chemical retrievals. That is why this satellite data is best used for trend analysis, so we can take many days and average them together. We will now look at some preliminary data from the more recently launched TROPE-OMI satellite. This satellite provides spatial resolutions nearly 9 times better than its predecessor, OMI. Remember that air pollution, climate change, and the size of the ozone hole in the stratosphere are all related because they're all caused by changes in atmosphere composition, of which human activity plays a large role. This researcher, Dan Goldberg, provided images comparing the NO2 concentrations from March 2019 to that from March 2020. Notice as the 2 images alternate that there appears to be a significant decrease from March 19 to March 2020. But remember, this data is still preliminary. Here are some observations we've made concerning the reductions in emissions during this COVID-19 pandemic. Keep in mind that early spring is generally a period with good air quality, and weather is a big factor with air pollution. Our ambient NO2 monitors throughout the state have seen a drop of 40% compared to previous years. If NO2 levels remain low through the summer season, We may also see a large drop in monitored ozone concentrations. Connecticut, working together for clean air. For further information, visit our website, ct.gov/DEEP/air.